All right, good morning, good afternoon, or good day to everyone. Welcome to lesson 4.3, solving equations with absolute value. So yesterday we talked about solving square and square root equations where we'd have like 0 or 1 or 0, 1 or 2 solutions. Now we're going to talk about the last type of equation, which is an absolute value types of equation. First step, though, I want to define what absolute value actually represents. Absolute value means distance from 0 on the number line. Okay? So, just to kind of throw a quick example, what I'm talking about here is this. Okay? So here's a number line, and here's 0. So for instance, if I take the absolute value of 5, here's 5. 5 is 5 units away from 0. So it equals 5. Just equals what it is. And that's true. All positive numbers, the absolute value is going to equal what it is. Now, what if I take a look at negative 5, the absolute value of negative 5? Well, that distance to 0 is 5 units. Distance is always a positive measurement. So, in essence, a lot of times students will think, well, basically it makes negative numbers positive. That is true. It actually does that. Now, the thing to remember, though, is it only changes negative to positive. It does not change positive to negative. So now, one of the things to note is that the symbol of the absolute value is these bars. Okay? So when something is in those bars, we consider it absolute value, okay? Which leads to then our absolute value equations. Okay? So an absolute value equation is any equation that has basically the absolute value of x in it. So, some examples, as simple as the absolute value of x equals 2, or the absolute value of x plus 2 equals 4, or say the absolute value of x plus 3 minus 7 equals 5. Okay? And I could keep going on for a very, very long time. Okay? Because when the absolute value equals a certain number, we know that it could be going in two different directions. Okay? So when doing these problems, what's going to actually have to happen many times is once you get the absolute value piece by itself, you actually have to set it equal to two numbers. Okay? And let me explain a little bit more with like number 1 using this graph. So here it says the absolute value of x plus 3 equals 5. Well, that means is this x plus 3 is 5 units away from 0 on the number line, which means it could be located at 5 or it could be located at negative 5. So when you get the absolute value piece all by itself, you, in essence, write two equations, kind of like the square problems. So we're going to say x plus 3 could be located at 5, or x plus 3 could be located at negative 5. So now I need to solve both of those equations. So x could equal 2, or subtract 3 from both sides, x could equal negative 8. So now, I can check this on my calculator. So, to get the absolute value symbols, you go math, hit the math key, and you use the right arrow, and you select number 1. So what I can do is hit the math key on my calculator, use my right arrow, and right there, ABS. So then I can type in. So like for instance, 2 plus 3, okay, take the absolute value of that. Does that give me 5? It does. So if I check the other one, absolute value. The other answer was -8 plus 3. Hit enter, and that also equals 5. And I know my answer's right. All right, let's take a look at the next one. So on the next one, we got a lot more steps to do. So I got to subtract 3 first. So I have 2, absolute value, x minus 1 equals 4. Then I need to divide by 2. So I get the absolute value of x minus 1 equals 2. Now that I got the absolute value piece by itself, I can write the two equations. So x plus 1 equals 2, because 2 is 2 units away from 0. And x minus 1 equals -2, because being 2 units away, I could be located at -2. So now, add 1 to solve. So I get x equals 3. Or if I add 1 here, I get x equals -1. So again, I can check. So I can go to math, absolute value, whoops, I forgot to hit the right arrow. To math, right arrow, absolute value. So I can plug in the first number, 3 minus 1. Move my arrow outside, plus 3. So now when I hit enter, I should get 7. So now I do the same thing. To math, right arrow, absolute value. This time I put -1 minus 1. Move it to the outside, plus 3. Does that equal 7? It does. I know my answer is right. All right, let's take a look at number 3. So now, I'm going to subtract 7, subtract 7. So I get the absolute value of 2x minus 5 equals -2. But wait a second. Absolute value represents a distance, and a distance must be positive. You can't be -2 units away from 0. So, in this problem, we have no solution. An absolute value cannot equal a negative number. Wow, that made that problem a whole heck of a lot easier. All right, let's take a look at the next one. This one actually looks pretty easy. I'm going -3 from both sides. So absolute value of x equals 0. Okay, well, how many units away are you from 0 if you're at 0? Well, that's just 0. So really, it would be 0 and 0, or just 0. So in this particular case, we only have one solution. So if I plug in 0 back here, 0 plus 3 is still 3. So that works out beautifully. All right, let's take a look at the last one here. Sorry, just trying to pick a different color. So this one looks like I got a lot of math to do first. So I got to subtract 6. So I have 3, absolute value, x minus 2 equals 9. Undo the 3 on the outside by dividing. So x minus 2, absolute value, equals 3. So that means I'm going to have two equations. X minus 2 equals 3, or x minus 2 could be located at -3. So now, add 2 to both sides. X equals 5, or add 2 to both sides. X equals -1. So again, I can check 3. Math, right arrow, absolute value. 5 minus 2, move it over, plus 6, better equal 15, and it does. Do the other one. Okay. Check it, and so the answer was, let's see, -1 minus 2, move it over, plus 6, hit enter, and I also get 15. Both answers are correct. So if you look here, in all of our different solutions, we could have 0 solutions like in number 3. We could have 1 solution like we did in number 4. And most of the time, like 1, 2, and 5, we could have 2 solutions. All right, so hopefully that will help you complete your 4.3 assignment. Good luck with that assignment.